Hello there, welcome again. Yes, it's been quite so long time. We never publish any tutorials. Sorry for that, guys. So here we go, another tutorial for you guys. As you can see here, we are receiving some data. Yes, from where? Yes, it's from Arduino. Okay. So with this, or in this tutorial, we will learn how to link our friendly friend Arduino to the Excel sheet, and we will learn how to receive the data. Okay, you see now this is a real-time data from Arduino through the serial communication. Okay, so this real data, you can do many things on it. For example, you can store it, record it, you can process it, you can do whatever you want to do. It's only plotting it and visualizing the data from the Arduino. There is the sine wave that's been drawn from the Arduino data. Okay, so we will learn all these things from these functions that might be useful for your project or the next project that might need to visualize the data on the Excel sheet. Okay, so if you're excited and willing to learn how to do these features and add it to your projects, stay tuned for it. Okay, let's continue. Okay guys, so the first step in this tutorial, we need to activate the data streamer or enable it. Okay, because these features is come enabled by default. Sorry, it's come disabled by default. Sorry for that. Actually, it's come disabled for all of us, and we need to activate it or enable it in order to use it in our projects. Okay, so how to enable it or activate it? We go to File. As you can see here, I open new Excel sheet. You go to File, Options. From here, go all the way to Add-ins. Then you go to this Manage List. From the Manage List, you choose COM Add-ins, okay, for the communication. Then hit Go. From here, you can see there's an Excel Data Streamer add-in. Okay, this is what we are going to enable. Again, Excel Data Streamer add-in. Hit OK. Then you can see the add-in. It will be added to your toolbar. Here we go. Streamers. Here we go. Again, from File, Options. Then you go to Add-ins, Manage, choose COM, Go, then enable the Excel Data Streamer. Okay. Anyway, if any of you guys couldn't find this add-in, if you couldn't find this add-in into your options add-in, if you can't find it here, if you cannot find it here or any of the previous step, you can download it and install it manually. Okay, you just go to Microsoft.com and search for data streamer, then you download the file and you just install it in your PC. Then it will be available for you guys to use it. Okay, and if I will remember at the end of the video, I'll include the link for the data streamer at the description, or maybe I will try to edit somewhere here. I will overlay it on the video if I remember the data streamer link. Okay, but most of the latest version of the Office, Microsoft Office, this data streamer will come embedded in. You just need to activate it or enable it. Okay guys, so the first step is done. Now we need to go to the Arduino side to write the code for this. Okay, Okay guys, so now we will develop the Arduino code to send data to the Excel sheets. Okay, so here I open new sketch, bare minimum sketch. Okay, so let's start. First of all, we need to initiate the serial with the power rate. We just go with the standard power rate, which is 9600. Okay, what we want to send to the serial? For this time, let's send very small, simple code, which is just we do a counter. Let's go up and down, up and down. That's all. Something like very simple thing. Before we go to the more difficult things. Actually, this one is depending on your code. It's no big deal whether you want counter or any data you want to visualize it, but let's start with the counter. So let's do a for loop. Let's say for integer I equal to 0 and I less than or equal, let's say, to 55, and I increment by, say, 5. We increase 5 times at each iteration. Okay, so add the block for the for loop. So this for need to be maybe here. Okay, so the for loop will do what? That's all. So that I will be looping from 0 to 255 with an increment of 5. Let's print it out. We send to the serial dot print line. We print what? Print I, and this should be all for here. And again, we need another loop for, I'm not sure if we need integer I here. For integer I, this time equal to 255, and I should be, yes, it should be more than equal than 0, and this time we will minus or equal 5. Okay, and again, serial dot print line I. That's it, but let's test it out. Let's compile Arduino. I believe I already connect the Arduino. COM11. Okay, let's burn it. Let's burn it. Okay, compiler happy. Let's check the plotters. So this one okay. 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 So yeah, this is what we expect. It's just a counter, go up and down, up and down, up and down. Okay, so this is our code. Looks kind of fast to me. Let's add some delay. We need to add delay. We need to add delay. Let's say, I don't know, 10. Here also delay of 10. Let's see how it looks like. Okay, compiling, happy, and now it's uploading. Good. Where is our serial? Hurry up. Okay. Looks nicer now. Not very fast as before. Okay, I'm happy with that. This is our first code. Let's see how it looks like on the, or in the actually Excel sheets. Okay, so this now with this code we have done with the Arduino part. We just send out the data. Where is it here? Send data to serial. Okay, so here we send data. Any data we need to send it to serial. So later we can visualize. For example, we have counters, data, your GUI, parameters, whatever. Okay, so now I will open the new, there it is. So this is new Excel sheet. Okay. I open many times. Okay, open only one. We go to data streamer. From data streamer, here we go. It's already added numbers of steps for you. First, you need to connect the device or import data. Also can. Then you can start the data, start listening to the data, I can say, or stop. Then you have an option of recording the data and stop recording, and also you can capture, like screenshot your sheet. Okay, so let's start to connect. We hit connect. Now we should see our Arduino. Here it is. It's Arduino on COM11, correct? We click on that. There we go. It's connected already. That's why it's changed to disconnect the device. And step 2 is already activate the start data. So when I click on the start data, here we go. So the data should come in at any time. Here it is. Okay. That's all. This is our data. Okay, this is our data. Okay, so this is the last data or the current data. And these are the history. It takes about 15 readings. And this is the newest one. So I mean, this is the history. This is the newest one. Okay. If you want to do whatever you want to do, you can just highlight. Let's say we want to insert plotted. Okay. There we go. But if you can notice, you cannot plot all because the data is kind of small. In the number of the data is just like 15. So if you want to increase this, we can go to settings. Here we go. So from the settings, we can change most of the things that you need to change, but for us, we will change here. And this is a 15 is the default. We can change to, let's say, 150 data or 150 row. So now if we come here, we see is changed to 150 already. Nice. So I one click here, Control Shift, go down. Here we go. So I highlight all of them. Now I go to plotted. Here we go. Exactly what we have done what we have seen in the plotter, in the CL plotter. It just counter go up and down. Okay, which is, can say, is a triangle wave. Yeah, kind of triangle wave. Okay, from Arduino. Okay, that's easy. Then if we want to stop it, we do whatever we want to do. Let's say I want to add on or delete or whatever I want to process, you want to do it. Okay, so we go back here. So I want to stop receiving data or stop listening. Just click on stop. Here we go, is stop. Okay, disconnect. It's disconnected already. You can connect again to the Arduino. Okay, this guy connected, started the data. At the same time, I can record this data. I can click on record data. There we go, it's recording now, it's listening. Then when I stop the data, it will show you where you want to save it. Okay, I don't want to save it for that now. Okay, so here's the live data. Okay, then I'll stop. So now I will show you the last part of this tutorial where we will develop the sine wave generator. Okay, sine wave generator from the Arduino, and again how we can receive it here in the Excel sheet. Okay, let's do it. Okay guys, so now we have reached to the last part in the tutorial where we'll develop the sine wave generator of the Arduino code. Okay, so if you check online, you'll find a lot of tutorials. They use the for loop to design the sine wave, where they use what they call emulate the time. Okay, from t equals 0 to t less than 360. Okay, and t increased by 1. Then they will write the output or the sine wave. Sine wave equal to the amplitude multiplied by sine sine pi divided by 180. Then this one will be added to the time, okay, etc. So this tutorial we won't follow this. We will learn new method by using millis. Millis are kind of more accurate. I trusted more than the time, and for sure at the end they need to add the delay to get the complete sine wave. Okay, so in this tutorial we will learn something new rather than the one online. So since we will use millis, so we have few parameters we need to declare. So let's have integer amplitude. This is for our amplitude of the wave of our sine wave. Sine wave amplitude. Then we have frequency. This is the sine wave frequency. Okay, what else? Sample. Let's declare this here. We have the sample rate. Okay. This is the wave sample rate in millisecond. Okay, what else we need? I believe that's all. And for sure we need to declare on the top. We need to declare the what they call the serial. Need to initiate it. Again, the baud rate we just go the default one, 9600. Baud rate, what else? Bit per second. Okay, let's go to the loop function. In the loop function, we need to use the millis. Since we need the millis, we need to have the previous millis. So previous millis is kind of very huge number. So it should be unsigned long. Okay, let's assign this to 0. What else? We need current milli, which also unsigned long current millis. Okay, the current millis we assign directly to millis. Okay. Okay, so let's continue. There is the millis. Now, what to declare? Next, we need to check the millis value. If the current millis, let's copy paste, so make it faster, minus the previous millis is more than or equal the what? The sample rate. Okay, we check it with the sample rate. Then if they are more than the sample rate, it means it's a time to take or calculate a one sample. So the previous milli will be assigned back to the current millis. Okay, then here we need to calculate the sine wave. Okay, so float sine wave equal to the amplitude we assign here, okay, multiplied by sine, two multiplied by pi, sorry, pi is a capital, multiplied by the frequency, multiplied by the current millis. Okay, this is the t, or the time that they use in the let's say online tutorial, the others online tutorial. And since this one is the milliseconds, so we need to divide by 1000. Okay, should be it then. Send the data to the serial. So serial dot print line, print what? Sine wave. Yeah. Okay. So compiler should be happy now. I guess we are okay. Sample rate, but not the, oh, okay. So since this one doesn't like it because we're only here, let's take this one and make them global. Okay. Let's check now. And by the way, let's assign some data to them. For example, amplitude, let's make it 50. Frequency, let's make it 1. Sample rate, also 1. Okay, let's compile again, upload, and check how it looks like. Okay, done, happy. Now let's upload it or burn it. Okay, done to serial plotter. Here we go, our sine wave. Nice and easy. Okay, now let's change the frequency. For example, I want to make it like 3 hertz. Now it should be faster. Doesn't like it. Okay, maybe we need to close this one first. Okay, it's uploading now to say upload. Here we go. Boom, 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 boom. But now, no, let's make it only 1, just for the sake of testing. And the serial plotter, just close it for time being. Okay, done. Check again. Here we go. Yeah, this is our sine wave. Okay, so now we have done with this. Let's go to the what they call the Excel sheet again. Here we go. New one. Brand new one. It's loading. Here we go. So this is our new one. We go again to the data streamer. Connect the device. As usual, then we go to Arduino Uno, COM11, yep, correct, then we start receiving the data. Again, waiting for it, here's our data. We see here just 15 rows only, so we go to settings, make it, let's say, 200. Now we go to data in, here we go, all our data is here, Control Shift, go up. Now we can draw, insert, blah, blah, blah. Yeah, there we go. This is our sine wave as we expected, okay? So now, this is all the data has been come from the Arduino, okay? That we send it from the Arduino MC using the serial library or the UART interface. Okay, you can use this function with many applications like GUI parameters, or even want to fine-tune your projects, or want to print some messages, or especially if for data logger. This is very important, very important. Well, before that, we need to use the ROM or external memory RAM. Then we later need to save it again, and using the USB, I mean, to transfer all the data to the UART or other type of communication, just for sake of data logger. But now you can do it very easy. And one more thing, this one is, I can say, it takes a lot of data. No need to be use only the internal memory of the Arduino, where it store very small amount of data. Here you can depend on the hard disk directly of your computer. Okay, when you go to here and start to record, it will directly record your hard disk. So definitely the hard disk is a lot comparing to the Arduino memory. Okay, so that's conclude our tutorial for today. I hope you have learned something new, and see you next time.